Hello everyone, and welcome back to the videos of your time at home due to the coronavirus situation. This is the first new video I'm making for this. It's been a while since I've made one of these, so hopefully it won't be too bad for you. This is part 2 of simplifying higher level rationals, and this is going to be a short video because we're just going to add on to what we did yesterday. And we're going to try to recap and reinforce what you did yesterday, where we did some factoring and we canceled out some values from the top and bottom to simplify fractions. And then we stated excluded values in our answer. Today we're going to add a little bit higher level questions, only higher level in the way that it's going to involve two-step factoring. Your homework yesterday had both GCF factoring and trinomial factoring, along with a little AC method at the end. But for today, we're going to see a lot of problems that are going to require you to factor twice before you do any canceling or reducing. So let's go ahead and take a look at our first question. So our first question is going to require us to factor twice and then reduce the fraction down. When we say two-step factoring, I have a situation here where I've created the highest level question you'll see today. And that's the type of problem where you have a top and a bottom that are both factorable, and they're actually factorable twice. And so you notice that on top you have negative 6x cubed plus 98x. That is divisible by negative 6 as a common factor, and there's an x in both terms that can be taken out. So I can factor the top down to negative 6x times x squared minus 16. That's GCF factoring. We've done that before. You did that yesterday. On the bottom, 4x squared, 4x, and 48 have a common factor of 4. So I went ahead and factored the bottom by dividing out a 4 as well. 4 divided by 4 is 1. 1. 48 divided by 4 is 12. So that's where all those values came from. So we took these higher level problems and we factored them. Now, the situation is, though, that we're not done, because x squared minus 16 can be factored more. X squared minus x minus 12 can be factored further. So we need to take another step here. When you look at x squared minus 16, that's one of those special cases of factoring where we have no middle term. We have a perfect square minus a perfect square. We called that the difference of squares when we were doing our factoring section. And the difference of squares simply said the middle term adds to 0. So it's going to factor down to negative 6x times x plus 4 times x minus 4. Because that plus 4 minus 4 will multiply to negative 16. But when you add them together, you get 0 in the middle. So that's a special type of factoring as well. So I took the top and I factored it. You notice I didn't ignore this negative 6x. It's still there in the answer. I have negative 6x, x plus 4, x minus 4. That's two-step factoring. I factored out the negative 6x and then factored the remaining binomial x squared minus 16. Down to x plus 4 times x minus 4. Now the bottom, you see we have this 4 in front, and then you have x squared minus x minus 12. So that becomes a diamond problem factoring where we say what numbers add to negative 1 and multiply to negative 12. Those numbers are negative 4 and positive 3. So that leaves our bottom factored down to 4, because the 4 didn't go away, it's still there. And then we factored this down to x minus 4 times x plus 3. All right, so we're ready to get to our final parts of our answer. The first phase of our answer is going to come from doing the reducing portion here. I see I have an x minus 4 on the bottom and an x minus 4 on the top. That's a common factor that can be divided out. The x plus 3 has nothing in common, so it's going to stay in my answer. X plus 4 has nothing in common, so it's going to stay in the answer. But we also have these factors in front. You notice negative 6 and 4 are both divisible by 2. So I can reduce both of those by 2. making us have a final answer of negative, sorry, let me move this around here so that it works a little bit nicer. And that's going to be negative 3x, because I can divide the 6 and the 4 both by 2, times x plus 4. On bottom, we're left with a factored form of the 4 divides by 2, giving us a 2. And let's make this all match up nice. So I got to mess with my sizing a little bit here. So we end up with a 2 times x plus 3 as our final form of our answer. So our answer ends up being negative 3x times x plus 4 over 2 times x plus 3. You can multiply those back out, but we're not going to require that because our goal right now is reducing and simplifying. So that gets us to our simplest reduced form. We do need to make sure, however, that we state our two answers that x can't be. X can't be 4, and x can't be negative 3, because those would be the two answers that on the bottom would make this would be 0 if x was negative 3. This would be 0 if x was 4. Both of those are excluded values. So we go ahead and slash those out so that we're saying x can't be 4 and x can't be negative 3. So this is our final answer here. Negative 3x times x plus 4 over 2 times x plus 3, as long as x isn't 4 and x isn't negative 3. All right, this is a very challenging example. You may have to go back and watch this one more time. All right, we have one little piece to add, and then we'll be done for the day. This final piece is something that's going to show up in your homework that often confuses people, so I want to get out in front of that. And we're calling this example 2, but we're not even doing a full rational. This is just a factoring issue that causes some people some problems. So you see here, negative x squared plus 11x plus 26. A lot of people will approach this as an AC method question because there's a number in front of x squared, that negative 1 is in front of x squared. In reality, it's easier to do as a two-step factoring problem because the negative in front is the only problem that keeps us from doing this as a simple diamond problem. So if you see something like this on your homework, you can go ahead and factor out a negative 1. When you factor out a negative 1, that leaves you with x squared minus 11x minus 26. Basically, we just changed all the signs because when you divide by a negative, all you're doing is changing all the signs. That allows us then to factor down to negative 1 times x minus 13 times x plus 2. Because negative 13 plus 2 is negative 11, and negative 13 times 2 is negative 26. So this is not a rational in the form that I gave to you. It's just a trinomial that we need to factor using two-step factoring. However, you're going to come across something like this on your homework, and I wanted to show it to you before you go on to that. All right, good luck with your homework. Hopefully everyone is healthy and safe at home.